Good afternoon, everyone. Welcome to the Client Agentic AI session. My name is Rahul Tikku, and I lead the client business here at AMD. What we decided to do today was, instead of boring you with 45 minutes of presentation, I'm going to take you through probably 15 minutes of how we're thinking about this business, some of the announcements that you saw on the main stage if you were in the keynote. I'll unpack that a little bit more in some detail. And then we're going to spend actually 15 minutes sharing with you how this is real. So we'll share with you demos of the agentic workflows, how we're making it real with some of the announcements we made with our partner Cisco as an example. And then if we have time at the end, we'll spend that time answering any questions that you guys have. So maybe 10, 15 minutes for that. So that's the agenda. So to get started, I'm going to start by playing a quick video for you guys. Is the audio on? Good? Okay.
You started with an idea, but now it's buried under billing questions, contracts, POs, scheduling, and paperwork. The work that keeps the business running shouldn't be the work that holds it back. Meet your new agentic office team. Local, private, powerful. When a complex billing question comes in, your agents jump into action, easily monitored via a detailed dashboard. They review the request, check the contracts, find the right PO, drafts the response, and can even schedule a meeting if needed. What used to take hours now happens in seconds. Working together on device to manage the routine, protect your data and IP, and save on tokens as you build. Automate the routine, reclaim your time. Scale from 1 to infinite, and focus on building the things you love. Advanced by AMD Ryzen AI PRO.
All right, a little tidbit about that video, by the way. That video was actually, the agentic harness that you saw in there is actually real. The team created that, and we showed that on the demo floor. It's actually an office worker persona, that first persona that you see. And how can we create an agentic framework that helps that office worker get a lot better at whatever they're doing? So let me take a step back. Over the past several years, we've been in this sort of co-pilot AI assistance era, right? Which is, we looked at all of these different personas shown here: office worker, road warrior, power user, tech expert. We understood how they spend their day, what they do, what tools they use. And then we looked at AI assistants and how they can actually give them superpowers, make them better in whatever they do. And those results are real. Those results that you see there across the personas are real results of how AI assistants made us a lot more productive. And so as you sort of think about AI, our perspective on AI is it's about hybrid. It's not the cloud versus the client, it's the cloud and the client. And the way we think about this is, look, as you sort of start thinking about the advantages of local AI, it comes down to security and privacy, such that sensitive data stays on the device and on the premise, and you don't ship data to third party by default. When you think about consistent performance, no cloud latency, no network congestion, you don't have to wait for connectivity. You can work from anywhere just like we do, even in a plane. Right? As you think about scaling your agentic framework or your AI framework, cloud costs can get really out of hand. And so cost is another good consideration when you think about local AI. And then finally, IT AI enhanced operations. This is really around taking security agents, deployment agents, health checkers, all of those things running on the NPU, instead of taking up CPU or GPU bandwidth, such that you can have the full experience of the laptop. So having said that, one of the things that we're embarking on is this agentic era, right? I told you we came from this co-pilot AI assistance era, where productivity unlock was maybe 10%, 20%, 30% better. In this agentic era, it's really a force multiplier. You're thinking about 2x, 10x, 100x productivity multiplier. And when companies can do that, they really unlock a lot of their employee potential. This leads to newer cure for newer diseases. It leads to all kinds of things that we could not have thought of before, right? So that's the unlock the agentic era brings upon us. And this is not esoteric future. I think if you look into your companies, look into your own workflows, I bet you many of your employees, many of your coworkers, you yourself are using a lot of these use cases. So some examples we use here are around software engineering, productivity assistance, doing research, customer support, customer sales. These are real agentic use cases that are in the workflows today. As I look at AMD, it's pretty clear. We pretty much have every agentic harness at AMD deployed, whether it's Claude, whether it's Cursor. We have those deployed at scale, and our employees are using that for a variety of tasks, right? So we're all already big users of agentic within the corporation too. So I'll unpack a little bit about what we're seeing and why local AI and local agentic PC makes sense. So one of the big trends, and this is data from Goldman Sachs, that says by 2030, monthly token usage is going to go up 24x. And so that's about 120 quadrillion tokens a month that will get used by these agentic harnesses. And so that's a huge structural change, and it's going to drive demand for compute anywhere there is data, right? It's not just going to be the cloud. It's not just going to be the private infrastructure, but anywhere where the data is, we will need compute to go handle that data. And because of this massive token growth, it's sort of driven by this idea of agent harnesses are using millions of tokens per day. And I'll show you an example later of our TCO calculator where we're seeing on average 6-7 million tokens used per day by some of these agent harnesses in software development use cases as an example. And so that's the big driver of the tokens. And then you can read the news clips on the right, but the big message here is token costs, even though the cost per token is going down, and as the token usage rises, the token costs have become a P&L item for most corporations, right? Most companies are dealing with hundreds of millions, if not billions of dollars of incremental cost of tokens that they have to figure out. And so this is where local AI PCs become very, very interesting strategic conversation in the AI infrastructure. So what is enabling local agentic PCs? One of the biggest things that's enabling is how smaller models are now performing at or better than frontier models. And these small models can now be resident in your PCs and make your PCs agentic by default. So one of the things that you have to look at across the workloads is agentic is not one workload. It's a variety of workloads and use cases that come together. So if you look at the chart that I'm showing, extra small models that drive quick assist like autocomplete, rewriting emails, that's a very good use case for a local agentic workflow, all the way to large and Excel models where you're using deep reasoning, autonomous agents that are, understanding your context, reasoning, working with other agents. Those might be actually good use cases for larger endpoint computing or maybe even data centers for that matter. And our perspective is we have one portfolio across the client team that can meet any of those needs. And so as you think about extra small to medium models, something like a Gorgon based notebook would be a great use for that agentic product. Model sizes up to 24 billion parameters can fit onto that device. As you move into larger models or multi-agent devices, the Ryzen AI Halo is a great device that meets that need, right, with 128 gigs of local unified memory, which can run up to 200 billion parameter models. And then in that particular product, you saw today earlier in the keynote that we announced Gorgon Halo. Gorgon Halo is the next generation, comes out in the September timeframe with our OEM partners. And that product will have 192 gigs of memory, so up to 300 billion parameter models, right? or you can run many more agents on that device. And as you go into agent swarms and think about those autonomous agents that are reasoning and working together with Excel models, you are starting to get into the territory of a Radeon Pro graphics card together with our Threadripper processors and a workstation class product, and that can do 500 billion to trillion parameter models locally, and has a lot more capability as an endpoint or edge device. All of this is stitched together with ROCm.ai, and you heard about ROCm.ai and how we're making that very simple to use. This is all stitched together. It's the same story across data center and client. ROCm stitches it all together. Now, having said that, I'll give you a couple of data points. When you look at the Ryzen AI Max processors, which is what powers the Ryzen AI Halo devices and many of our partners' devices, these products perform much better than some of the competitive products available in market. You can see on the left side, 130% better performance across 9 generative AI workloads and 3x more system memory when compared to an Apple MacBook Pro M5. And then as you sort of think about comparing the Ryzen AI Halo box on the right side to Apple Mac Mini M4 Pro, 340% better across those Gen AI workloads and 4x more system memory available. You've already seen the box. It's right here. If you haven't seen it, go visit the Expo Center and you'll see a lot of it running. I did want to reveal a device to you guys. One of my daily use machines that I use for my agentic workflows is a 14-inch HP notebook that I actually love. I use it. It's in my backpack. And we are working with HP to bring this device to market, which is a 16-inch device, beautiful, fully professional, enterprise-grade device that has the same Ryzen AI Max CPU. So whatever experiences you're getting in this Ryzen AI box and all of the software experiences, we'll be bringing 2 devices like this from our partners like HP. So really excited about that. Thank you, HP. I know that you guys are in the audience. And then as we sort of think about the world of systems that support the Ryzen AI Max, the point I want to make is we have 30+ systems available in market today. This is not a roadmap promise that's going to come in the future. These systems are available in the market as we speak today and have been for a while. The Ryzen AI Max next generation, the Gorgon Halo systems, will be available in the market in the September timeframe, and we have 20+ products in development across form factors with the Gorgon Halo product too. So again, very excited about that technology. Okay, so I told you I'll show you a little bit about token costs and how tokenomics is playing a part and how the local AI PC can help solve that. You're seeing here typical cloud agent user, about 6 million tokens a day, $770 spent in monthly subscription costs. That can add up pretty quickly. In the end of 3 years, you're looking at about $28,000 spent on renting cloud space to go run your agent harness. And by contrast, you can look at the Ryzen AI Halo. Again, it's a $4,000 system with very limited operating monthly cost, and that pays for itself in about 6 months. And this is really on the lower end or the typical end of what we see people spending on agent costs. I've actually talked to customers all over the world, and several times I've heard token costs averaging in the thousands of dollars per month per employee, not just $770 shown here. So again, very, very important considerations that CIOs have now to go figure out how to control costs, and this could be a very strong play in that space for CIOs. Now I'm going to unpack a little bit about the software pieces that you heard about today in the keynote. So the way to think about this is, look, hardware runs the model and software runs the agent. And so the hardware is on top of what our models run, but the 6 layers of software shown here are the layers that are required to go run the agent in an enterprise space. So layer one is around inferencing and routing. So when you think about that, local LLM model served on that layer one with a semantic router that is making sure the right model is served at the right time, at the right cost, whether it goes to the cloud or stays local, not at deployment, but at request time. Layer two is around skills and capabilities, and that's really discovering reusable tool bundles. So if you paid attention in the keynote today, we released skills as a part of Rockem.ai across the various agentic harnesses. Layer three is the actual agent harness, and so whether it's Claude, Cursor, OpenClaw, or Mace, we support all of them, and those all are needed to be able to have a good agentic PC. And then layer four is around applications. This is really us working with the ecosystem of ISVs and developers and making sure there's a rich ecosystem of applications that can use the agent workflows. Layer five is really around security and sandboxing, running your agents in a secure way. And then finally, the layer on top is IT. This is where governance, observability, policy control, manageability, deployment all comes in, right? That's sort of the layers that you need to be able to have an agentic harness in the corporation. And we're working with Windows on this, and we're working on Linux for this. And so when you look at Windows, it's critical because this is really where the enterprise seat count is, right? Most enterprises deploy Windows. We want to have a really good experience for our Windows users. And so we're mapping our OpenStack onto the Windows ecosystem. So when you think about some of the Windows pieces, Agent 365, which is shown at the top, is where Intune, identity, enforcement, all of that work happens. When you look at sandboxing, Microsoft has MXC that they announced at Build, and so MXC is what we're using for sandboxing. That is together with the AMD containment extensions that we have. When you look at the first-party and third-party apps, Microsoft is working on agentic first-party and third-party applications too. Windows is a super rich application ecosystem, and so we're pretty well positioned in that ecosystem. And then finally, as you look at sort of the inferencing area, you're talking about Windows ML and Aeon models that are optimized for the Ryzen AI Halo and the Ryzen stack. So we're very excited about our partnership with Microsoft. And then when you think about Linux, I get asked why Windows, why not Linux? I don't think the answer is Windows or Linux. It's Windows and Linux. And it's pretty simple. Enterprises are deploying on Windows. Developers are building on Linux. That's sort of the story, right? And so we're enabling both of those stacks. So when you think about the Linux stack, we have identity, observability, and governance through partnerships like the Cisco partnership that we announced today. We have AMD Axis, which is our substrate for, similar to MXC on Windows, it's our substrate for agentic execution in a safe sandbox. We have AMD Skills, we talked about that. Lemonade is where we serve local models, and that's where we build the semantic routing too. So that's sort of our Linux stack. And we'll show you some of this in the demos. And so as you sort of think about the stack, there's really 4 beats in the stack. And so it's around protect, run, route, and act. And so what that really means is we want to protect with access. That's agent execution isolation substrate. That's where we're sandboxing the tool calls and all of the actions. File system calls, any process and automation isolation that we need to do, that's where it's done. We run Lemonade, which is where all of our local AI models can be gotten out of. And then we did this cool, interesting new technology. We announced it. It's called Extensor. And that's really taking large language models, and they'll be stored in SSDs instead of memory, and served as needed from the SSD or prefetched as needed from the SSD. So you'll be ready when you're ready to execute that agent using that particular LLM. And then from a route perspective, the semantic routing is built on top of VLLM, and it's part of our Lemonade stack. And it allows us to look at the requests and direct them to local or hybrid AI infrastructures. And then finally, All of the AMD skills are reusable capabilities such that you don't have to figure out how to put frameworks and different pieces together. It all comes together with skills easily, sort of like what you saw in Rock'em.ai. So that's sort of our stack that we're enabling. This stack blueprint is available on GitHub now, and we'll be productizing it by the end of the year. So that's sort of our strategy on the stack. The other thing that we're announcing today is that we're going to be bundling AMD Developer Cloud credits for users of the Ryzen AI Halo system. And those cloud credits will be available by the end of August. And you'll need to show a proof of purchase of the Ryzen AI Halo system. And the reason we're doing this is pretty simple, which is, look, we think of Halo as the local development box, but then you might want to sandbox and test things on the Instinct Cloud with us. You're able to do that. You have free credits to go do that. So that's available to you guys too. Okay, so I'm going to wrap it up, and I'm going to invite my friends over to do the demo. So really, I want you to walk away with 3 things. Again, I said I'm going to keep it short and sweet. Agentic AI is really a game changer. People have asked me for years now, what's the killer app? The killer app is your agent. That's really the killer app. Tokenomics is driving the need for hybrid infrastructure. The costs are getting out of hand. There's obviously other elements around security, privacy, latency that we talked about, but really tokenomics is driving the hybrid AI infrastructure over to the endpoint. And then finally, if you think about AMD, Lisa laid it out very well today, which is we have a very broad end-to-end portfolio. Cloud to data center to client to edge. And we're stitching that portfolio together with the Rock'em.ai layer, and it's all built for this agentic era. So with that, I'm going to invite Yash, who's our partner at Cisco, and Ian to come on stage and demonstrate some of these technologies real time to you guys. Thank you.
Is this working? Hands up in the back. Great. Those were the longest 5 seconds of my life when someone switches an input to a different one and you wait for the screen to come up. So I'm very happy to see that that did happen. Hello, everyone. My name is Ian, and I am here today to talk to you about making practical some of the concepts that Rahul brought up. And before I jump into the demo, which will be I'm going to hit a run button and you're going to see various things happen. There's a few technologies that I want to double click on just a little bit, and we're going to bring it back into a context related to IT security and enterprises, because everything that's happening right now in agentic is happening in real time. Everyone is disoriented. We're figuring out very quickly as things are changing, but they all have corollary experiences and stuff that we've all worked in forever. So we'll start with a few. By the way, the other thing to know is everything you're going to see today was created with the tools that we're talking about, live running on Ryzen AI Halo, so this device that's here right now, and everything was created using AI tools in a hybrid method. So let's get started. The first thing, the harness, so the agentic layer, Claude code. The top end of this interface, you'll see a prompt. When I hit that prompt, when I push it through, it's punching through to a CLI interface in the background and being processed by Claude code. So the Claude code is agentic layer. It's the reasoning and the use case, the tool use engine that takes the ticket into action, does the tool calls, executes the multi-step work, whatever is needed for the complex reasoning, for like a capable teammate. And the key benefit for that is that it does not matter where the brain lives. If the brain is local via Lemonade, then that's fantastic. If the brain is within the cloud, whether that is Anthropic, whatever it is they're using, OpenAI, can be wherever it is. So this demo is going to show you that simplified UI that will show it punching through to these other concepts. Second is Lemonade. So Lemonade is where we get the serving and the least cost routing. So our local inference server that's fully compatible, as I mentioned, with OpenAI and Anthropic, is making the routing decision at each request. It is the semantic routing layer at that point. And a semantic router can be configured any way that you like. If you take it directly outside of the box, it's going to look at the weight of the activity coming in, look at the estimated token count, and then make a decision on complexity, whether it needs to go to cloud or can be kept local. Just wondering if I should, I'm not going to bury the lead here. So in the workflow that you're going to see, about 70% of the tokens will stay local. And for most workflows that we see right now that are general office tasks, that are relatively mid-complexity models, that'll hold. So anyone in the audience would like to save 70% of their tokens? Okay, good. Well, I'm seeing lots of engagement on that point, so I'm glad to say that you'll see that reel in a second. Automatic least cost routing, I believe that that's probably something that should excite people in the audience. You only pay the prices when the task earns it. Third concept, policy guard. In this case, this is our way of thinking about, imagine the world in the security world, the firewall or intrusion detection layer. And I'm being specific, detection versus prevention. So with the firewall, you can put in the rules that allow you to govern that which you wish to be permissible in your environment. Now, note that I didn't say it's the only security layer. That's the thing that you wish to be available. And a declared policy can then flag and can stop known bad requests that are happening at the door. But a policy is only as good as the person who writes the policy. So access, being the last point here, would map in a security environment to an intrusion prevention system. Access will not let you do anything that you should not do. So in the background, what you will see is as I run this demo, I will turn on and turn off the policy layer so that you'll be able to see what occurs. Now, when I bring that back, policy guard decides whether to run it. Access decides where and how to run it. The two are in conversation. If one of them says something and the other says, man, we should not do this, access wins. So that'll just give you the idea behind this. Now we're going to jump into the demo. So the use case that we have up here, the scenario is a customer support ticket triage system staffed by AI agents. And the tickets will stream in automatically over time. Again, I'm mentioning this is live as we go through here. An agent will look at each one of them, make the tool calls, and draft a resolution or an escalation. So directly to conclusion. So everyone in the world of IT and in terms of trouble talk about first call resolution. Well, imagine if it was first token resolution. Something comes in, auto response can go out, problem solved immediately. But some of the tickets that are going to come in will have private data or will have prompt injection attacks, will have the kind of stuff into it that we know that we don't want to happen. So the question that this demo is meant to illustrate and answer is, how do you let agents work in full autonomy while having the confidence that your enterprise can be protected with policies and tools that we control? So that is exactly where we are. In the interface, by the way, as we go through this, and I will invite you, if you're interested in a deeper view, to come to the demo showcase where we will be showing this demo. It will be a little challenging to see some of it up on screen, so we'll happily do that later. Prompt at top, a ticket resolution dashboard in the middle that just talks about tickets flowing through, what's happened to them. I will show the hybrid routing flow and describe as we go through the steps. And then, of course, the token usage, which I believe will be very interesting to people, as well as the security dashboard and what's happening in individual tickets. So I will be moving around a bit in this interface. It's lower resolution than the screen, so it's going to jump up and down a little bit as we go. So the demo. I'm going to focus on two cases for that demo today, with security being at the core. So at the top right, you'll see that there are two toggles. One of them is about the semantic router. We're going to leave that on today because I'm pretty sure everybody wants all the tickets to flow locally as much as they could. I can switch that off and force it either direction. We won't do that today. The other is for policy guard in enforce mode, which means that the policies are active, or in a monitor mode. So I'm going to do that because I want you to see what happens when we have an attack that occurs, even though the policy is off. So I'll just start it right now with the enforce mode on. Okay, use this screen that's resolving correctly. So what you'll see in the interface in the middle is the tickets start to flow. When they flow green to the bottom, they're going local. When they flow in the orange direction, they're heading north. That is into Claude. And this isn't scripted. They're arriving over time. The agents are reacting. They are triaging, reasoning. They are resolving. So as they're going through each one of these, there's a customer request that comes in. I'll jump down to a representative ticket. And you will see that inside of that ticket, the analysis was done. The resolution was to send an email back to customer. We're investigating your duplicate charge. A refund will be processed shortly. So that's what happens in this case. So each one of these gets resolved as you move through, but some of them are not resolved. We're going to get into that in a second. So the order of this as we head through, though, is illustrated up here in this diagram. Ticket comes in. It initially and first goes through the policy guard. That policy guard is the security layer. Now, one of the important questions in the past couple of months, we've heard things like, my open clause is unrestricted, it can do anything. My agents are unrestricted, they can do anything. This is the way that we create that framework around them so that they cannot do anything. They will do what it is that we want them to do. Safety happens first, runs through there, then into the semantic router when the routing is decided, whether it's going to go local or whether it will go to the cloud. So at the bottom right, you will see that there was something caught, but I'm actually going to go a little differently here and jump down into a blocked ticket. So in this case, when you see a policy guard ticket, what happened here is that there was an attempt to connect to the AWS credentials, and Access said absolutely not. That is not something that I'm interested in doing. Why I'm pulling this up is because as we continue the demo and I jump into the monitor mode, you will see that that tool call is again rejected, regardless of whether or not the policy is implemented. So we do need to let the demo come to an end, though, so that I can switch modes, and it has done so. Now, I don't also want to not excite people with the piece that's going to make them go, wow, and here it is. So the token usage that we're looking at here, 62% of them stayed local. Imagine what the impact would be inside your enterprise if 62% of your token bill disappeared. Now, the next question that would go through my mind if I were having this is, what if I turned that off? What if my policy element was missing? So without bearing the lead as we go forward, I won't make you watch this all again. You can if you want to, please do, or you can look up here. But what you will see is that Access still holds. So in the case that we have said, for whatever reason, we're defeating our security architecture, it will watch and wave things through. It won't necessarily wave everything through, so it will look at it, and against policy, it may not touch the least critical things, but if there is something that is a significant attack, Access will still catch that. So the goal here is we can't hurt ourselves. So if we're asking ourselves the question, what does it mean to live in a world where we have unrestricted agents, we now have an answer to that question. So what I would say then is to take a step back. So let's take a step back and talk about what it is that we're really looking at here. Every enterprise is going to run into an environment where agents become critical to their operations. They are going to be open-ended, there's concern, and there's lots of concern, and it's reasonable to be concerned. There are worrying things that could happen there of what they would be capable of. So the question that decides whether you deploy them will come to, can you box them? Are you able to do so? Today, you saw that answer on a single Ryzen AI system. And again, I invite you to come to the Solution Expo. We are more than happy to take you through this and show you the details. But Policy Guard is a detection layer, Access as that additional layer of security, enforces by intent, and it holds the final call when all the rulebooks fail. So your worst case scenario is a malicious attack is not going to be entering into your network. It enforces by that, and underneath it all, the router keeps all of the work keeps the appropriate work on the device, the semantic router, so your costs will stay rational. Rahul talked about being able to do many of those tasks on device. We are seeing, again, an average of roughly 69% of tokens staying on. If we step back to previous models that were available earlier, it was lower than that. As local models evolve, we expect that to go higher. So until now, we didn't have this, and now we do, and we have security, enterprise safety, and policy management that's at the front and center of Agentic AI, not bolted on afterwards. And that's the shape of agentic computing today. fully available today. Now, the next question that's going to come up is, what about enterprise scale? And as we get up to that, everything I've shown you is running on one Ryzen AI Halo endpoint, which is autonomous, cost-aware, contained by design. But now try to picture 10,000 of those. And as we get towards that level of scale that I think many of us are already seeing the ramp in demand heading up towards, what do you do? So how do I manage that? And that's exactly where my colleague Yash at Cisco comes in. What you've seen is this single trusted endpoint. Cisco Cloud Control turns that into a fleet with policy that can be pushed centrally, with telemetry aggregated, with all Ryzen AI devices, governed from a single interface. And with that, let me hand it over to Yash, who will show you how this scales from one to enterprise.
Thanks, Ian. Check. Can you guys hear me? Yes. Yep. All right. All right. I'm going to switch it in a second. Just one second. No, the slide didn't load. Okay, 1 second. All right. It's pretty ironic that we even switching screens is a bit of a pain these days, and we're going to talk about switching agents. It's, great to be here. I'm Yash Sheth. I lead engineering and research for Cisco and Splunk's agent resilience business. What we're about to show you today is exactly what picking up from what Ian was talking about. Today, Jack and Jeetu at the keynote announced our AI resilience solution on top of AMD's Ryzen AI Halo devices. We all heard the benefits of local inference, and we're seeing that across the board. With the growth of local inference, we'll soon see hundreds, if not thousands, of devices running agents across the enterprise, and they all need to be resilient in order to scale. Cisco's Cloud Control allows us to manage and govern all of our entire AI footprint through one single interface. Now, what we're seeing here is there are 4 AMD Ryzen AI Halo devices in 2 separate locations. They're in 2 separate labs connected via Cisco's smart networks. And at this point, we can actually have Cisco's identity service engine allowing IT managers to configure and provision these devices all remotely with role-based policies and network permissions to define what each device can access and what the agents on those devices can and cannot do. Not that, we can even, at the tips of our fingertips, we can actually quarantine these devices from all network accesses. And let's do this here for one single device. Live demos are always tricky, especially across VPNs. But what we're able to do here is quarantine devices that from all network access so that we can go into remediation and investigation mode, identify what's the critical failure or security threat that's going on these devices. Now, as we go from having control around, and you'll notice this theme across the board where this is all about governance and control across various layers. Next, we go from the network layer to the agent behavior itself. Now, tracking agent behavior is key to understanding and uncovering any unwanted activity happening on these devices. We're going to run non-deterministic workflows on these devices, and understanding and knowing what's going on, like not being blind onto what's happening there is key for us to scale. Now, Splunk's agent observability, infrastructure monitoring, and defense clause agent enforcement have integrated with Lemonade Inference and Access Sandbox here to be able to give us deep insights on what's going on with these agents, what's the device consumption, and even enforce policies and controls right from here to across all your agents. The policy builder here allows us to define our policies in natural language. You don't need to be an OPA ninja or be able to understand the jargon here. This allows us to create policies and enforce them in real time. What we're going to do here is actually create policies for a very common use case. We see agents are constantly known for deleting files, deleting tickets in an unwanted manner. And what we've defined here is for the same ticketing agent that we saw, we've collaborated with the AMD team on this, and we have these same agents running in the lab environment that we just saw. In this case, we're going to deploy two policies. One is to disable any kind of Jira ticket deletions. We don't want the agents to be our program manager, in this case, to delete these tickets, and even limit file system access. Using the policy builder, we created these policies, and we can enforce them in real time. I'm going to enforce a couple of them here, and the file system one as well. And now we can see a codex session that was able to delete tickets before. You see how it actually deleted ticket number 1, 2, 3, 4 in this case, and when we actually have the controls enforced, it gets blocked all on device locally. Again, there's no remote call from these devices to a central server for these guardrails. They're integrated into the agent harness itself, along with the access sandbox that Ian just showed us, to all be enforced locally. Now, once we have, and we'll see that in this particular agent, we have about 28 different controls, 25 of them are enforced, and we can actually define custom policies and controls across every agent. Now, once we have controls and guardrails defined on the agent behavior, safety, security side, the next big challenge is the cost. We all heard from Rahul and from Ian, about the amazing benefits of local inference. Now, as our agents start consuming more and more tokens, we've seen this, we've seen this trend, we've seen this, how this plays out. We're seeing at Cisco that sometimes an agent can cost thousands of dollars in a day, and you can't do anything about it. And that's the piece that we're trying to solve when you have thousands of these agents running in the enterprise. The tokenomics view here allows us to go dig deeper, not only from the high-level aggregates, but into every single agent, and help us plan our local inference strategy better. We can go into sessions that are ranked by the token sizes here across all your agents, and even go much deeper into what model was used, why was that needed, in order to make the decision much better. Now, you see here that this session with a million tokens, a single session with the million tokens was all local, versus there was Claude and GPT 5.5 that was used by an agent that was running on the same device. Now, the next piece is infrastructure. We'll have all of this compute, whether it's on our laptops, our desk-side devices, data centers, or cloud. How are we actually utilizing that compute and actually creating value out of the compute that we've invested in? And the Ryzen AI Halo devices actually integrates really well with Splunk's infrastructure monitoring capabilities, allowing us to see not only GPU efficiency, but also identify devices that have available compute. So now, this is how Cisco's AI resilience solution comes together. Like, with all of these capabilities built in one single interface, Cisco's Cloud Control allows us to manage our entire AI fleet as we scale. Now, we all know that it's not just one single thing that we have to take care of. Like, when we think about resilience, it has to be right from the network layer to the agent behavior, from real-time tokenomics insights to runtime guardrails and controls. That is what actually completes the whole resilience story in an enterprise. So as we expand our AI fleet, whether it's to automate our products and processes or transform our productivity needs, how do we think about AI resilience? We have to make sure that we build the AI stack with resilience in mind so that we can scale responsibly. Now, this particular demo was only, I'll probably go back to this slide in a bit, but this particular demo was only for the desk side devices, but this solution scales seamlessly for the world of hybrid inference, whether it's desk side devices, laptops, data centers, or the cloud. In an enterprise, we have to have a holistic view and leverage the amazing compute that's available on our fingertips. With that, I'll turn it back over to Rahul. Thanks for having us here.
Thank you. So that was it. Hopefully that made it a little real for you guys, right? Some of the technologies we're talking about, like I said, we have strong partnerships with Microsoft. We're bringing enterprise-grade technologies with them to market. On the Linux side, we introduce our own sandboxing technologies, policy guard, semantic routing, Lemonade serving local LLMs, and then working with partners like Yash here to bring it all together for the enterprise. These technologies are in blueprint mode, meaning they'll be ready for a real product by the end of the year. And it's similar with the Cisco team. We're working closely, integrating all of these pieces together, so they're ready by the end of the year for real-time enterprise deployments. So that's sort of the timeline we're looking at. Thank you all. Now we have some time for questions. If you guys have questions for me, Ian, or Yash, we're happy to take them. Go ahead. And I'll repeat the question for everyone.
You spoke about this tool to get LLMs on SSD. Can you elaborate a little bit about that?
Yeah, so we have this technology called Extensor, and that Extensor technology is actually allowing us to have large language models available on SSDs. Memory costs are a little out of control right now. As you sort of think about large models, you can have those large models reside in the SSD and be called in as needed based on prefetch technologies that Extensor enables, right? And so that allows you to best utilize your local memory.
And is it a paid tool, or do you get it for free with the Ryzen CPU?
It's actually, we just announced it in April, May, our paid tool, mainly.
Yeah. Okay, go ahead.
So you talked about semantic routing. You agree that that's probably the most critical aspect. Is that stack something that you're writing internally, or is it a third-party stack? You talked about, if I'm saying correctly, analytics.
Yeah.
Which models used and why?
So I think there are two. So the gentleman here was asking about our semantic routing technology. There are two answers to your question. On the Microsoft side, there's going to be a semantic router that Microsoft is going to have in their Agent OS, right? And so we're going to align with them. We're going to use them. On the Linux side, we wrote our own semantic router. It's part of Lemonade. And so if you guys are used to using Lemonade, it's a tool that we've had out for a while. It serves local LLMs, so we built this into it. It's based off of VLLM. So that's the base technology that it uses. It's available now on GitHub, so you're able to use it. And then as I sort of look at the world of Linux, there's a lot of semantic routers now available through various enterprise-grade Linux providers too, like Red Hat and SUSE, et cetera. So they have their own semantic routers too.
Yeah, I'll also add to one more point there. I think routing is a crucial space for all of us to think about. I think it's not a solved problem as of today. There's how do we determine which model is the best for your agent? That's an ongoing thing that the industry is evolving around.
Yeah.
Go ahead.
So in an enterprise, where do you see Ryzen Halo residing? Like, is this inside a server in their own data center, or is it a desk side graphics card?
I think, so the question was, where would the Ryzen AI Halo reside? So I think I'll give you a couple answers. First, the Ryzen AI Halo is driven by Ryzen AI Max processors. Those Ryzen AI Max processors are in systems of all different kinds, all-in-ones, laptops, small desktops, big desktops, workstation devices. So you can actually carry these devices with you as a personal computer, and it's also your agentic device. Now, what we also find is there's probably a need for +1 desk-side computing that most people who are heavy users of agentic workflows are going to have. So for example, me personally, I have a desk-side Ryzen AI Halo running, while when I'm on the road, I have a laptop that I carry with me. I talked about the HP laptop that's also running a Ryzen AI Max processor. So I have two devices that help me from that perspective. We're also going to be enabling clustering on these devices. So as you sort of think about that use case, that will be enabled by the end of the year on these devices. And then we're seeing use cases where some of these devices are going into server racks too. I was talking to one of our partners, Framework, earlier, and they sold 10,000 of those on a very big, let's just call them an entertainment provider company that is using them on a server rack to go serve recommendation engines. And so there's some interesting use cases. So a little bit of everything is my answer.
I think the era of ambient agents is here anyways. Like if I'm just running something on my laptop and I have one, I have a device too, and these agents are meant to be like running 24/7, and if I just shut my laptop and I'm headed back home from the office and it just stops working, like how does that shouldn't happen. Like we can leverage a lot more productivity.
It's funny, we're in a tech-centric city, San Francisco. I was with an analyst who lives here. He's like, I'm seeing a lot of people walking around with open laptops with agents running, and that's how they're walking around.
Right.
Like, really? That's a thing? But that's become a thing.
And as you think about how some of the demos here were developed, for instance, back in my lab in Markham, I have a Ryzen AI Halo running that has a Hermes agent basically running on it that I'm chatting with on Telegram basically 24/7, executing work. So not walking around with a laptop, but certainly walking into traffic while looking at my phone. So.
What other questions can we answer? Go ahead.
Oh, thank you, George Winch. Not everybody is capable of setting up those agents and so on. So probably most of the people that I know would use the prompting locally, I assume. And the benefit for the company is that you don't place your know-how into some cloud system. I think that will be the benefit. But how would you enable standard workers to utilize it more than prompting? I think this is maybe a task for IT guys to set up a complex workflow with agents.
Yeah, I think there are several things. Maybe, Rakesh, I'll invite you to answer how we think skills. I think one of the questions is how are we making it easy to set up agents? I think that's the first question. And then the second question is how do we help employees to use the agentic workflow? I think that's a different question, but why don't you answer how we're making it easy?
Great question, and that was the philosophy behind building this box. We came up with playbooks. You can go AMD playbooks. There's a set of validated recipes that you can follow and start running any, like an LLM on the box. Our score was we want to get from a power on to tokens in minutes. Then we figured out people are not reading a lot of these playbooks anymore. There are agents who are actually reading it from them. Right? So our next roadmap is how can we develop AMD skills, which can actually be a single line call. So we're integrated into a lot of these popular harnesses, and we announced some of those skills locally integrated. So where we're going for now is you can open up a Kotlin or an OpenAI, you have an AMD skill, you just use 2 or 3 words, and you can start getting things done on a local machine.
It's already becoming very easy to download, like from skill marketplaces, to just download different skills, whether it's to make like analyze, financial statements, and So.
Yeah, I think part of it also is we're at a place where people are learning as we go. I'll tell you, even at AMD right now, even in my own team, we deployed agents to go do demand supply forecast planning, right? Once we did that and we saw the value of how much time it saved and how accurate it was, we then held webinars with other groups that are doing similar work to train them on how we use Cursor to go what we needed to do. And so the entire demand supply planning forecasting process within AMD became agentic now, right? So some of it is also you're learning from peers, and then they did workshops for other users to see how we're using Cursor even outside of the demand supply forecasting. So that's happening too. I've seen, again, I use this example quite a bit. I live in a neighborhood, there's a lot of small business owners, lawyers, doctors, and when Claw came out, they were all testing and working on Claw, and it was solving real problems for them, and they taught each other how to do it, right? To my chagrin, they were doing it on a Mac Mini, which we'll fix. But the point is, right, is there's a lot of grassroots learning happening in this, and eventually I think it'll get easier as we figure out mechanisms to deliver these things, skills and other things much easier to end customers. But right now there's a lot of learning among work groups that's happening.
And we built some blogs inside AMD that you can find on amd.com that make this dead easy to install and operate a Claw. You mentioned that you're in IT. So inside our demo department, we built a competitive intelligence tool with the intention of it being only for demos. It very quickly gained flight into the product marketing team, and then product marketing team members were asking questions about how do I set this up? I have a laptop that can do it, pointed them to a blog, and as Rahul is saying, virality suddenly started to extend. It's easier than it sounds, and if you want to come by the demo showcase later, I'm happy to show you the tools we put together to make it easier.
Any other last questions? Go ahead.
When's the Ryzen Halo running 18?
It's September, will be in market. All right. Thank you guys. I appreciate you guys being a great audience. Thank you.